Yeah, this should be live in a moment. Okay. Mm, okay, I will open this up. Yes, let's begin. Okay, so binary tree longest consecutive sequence. Binary tree longest consecutive sequence. Not submitted this, okay. Given the root of a binary tree, return the length of the longest consecutive sequence path. A consecutive sequence path is a path where the values increases by 1 along the path. Note that the path can start at any node in the tree and you cannot go from a node to its parent in the path. Note that the path can start at any node in the tree and you cannot go from a node to its parent in the path. Hmm. Amazon and Facebook. The number of nodes in the tree is in the range this, and then this is something which will happen, right? One, three, four, five, and then 2. So 1, 3, 4, 5, and then we have a 2 here. So maybe if this is the root, then from here, if I start the process, it could be that my answer will always be 1 because a number in itself can be considered as, yeah, a number in itself can be considered as that. So I'll say initially answer is 1 because I can just take any node and that should be my answer, right? But I want to have a maximum value here. Okay, so answer is 1. So now in this case I can say that, okay, in the root we have, let's say, 1 comma 1. Now I know that since 3 is increasing, but it should be increasing by 1, not just simply increasing, right? Because path where the value increases by 1, not some random value. So 1 to 3 it's increasing, but increasing by a value 2, so hence I won't consider it. So again at 3 I'll say that, okay, at 3 the value would be 1 itself because it's not increasing. Now what I can say is at 2 the value would be again 1, but at 4, since 4 is increasing by 1, so the value here would be probably 4 comma 2. Now at 5 the value would be probably 5 comma 2, And I think so this will go on right in this way. End of the day, whatever the max value is here, that should be my answer. Okay, so we can go for I guess we can go for let's close that. Let's do this. We can go for a very simple level order traversal. Yeah. So for that, let's say I will take in this value. So dq from collections import dq, and then let's say my q is dq. So let's say q dot append. I'll append in the value which is in this case the root. Also, if root is not, I mean, if root is none, which means there is no tree, then in that case, I think so I need to return 0, because that will make a lot of sense. This is like an edge case, so I can write an edge case here. Else my max value or max increasing length is always 1, and I know why that is. So in my queue, I'll not only append a root, but I'll also append it in this format. So root comma 1, wherein first value is node, whatever the root is. I mean, in this case, it's a node, and 1 is nothing but the current length. That's it. So current increasing length, right? So current increasing consecutive length, something like that. So let's say while q, and let's say I'll simply write my current node, and what's my current length? That's, let's say, length would be q dot pop left, q dot pop left. Now q dot pop left, right? So I'll explore the other nodes, right? So I can simply say that, okay, if my current node dot left exists, right? So it means it kind of exists. So I'll say that, okay, my left value is current node dot left dot val, right? Yeah. Now I'll say that, okay, if my left value is equivalent to my current node dot val, in that case, I know that this is one of the increasing sequences. So I'll append, I'll say q dot append. So I can say left value will be probably this, and then left value dot val is equivalent to current node dot val. Then in that case, I'll say that, okay, let's append the node. In this case, that's left value. And what will be this? That will be length plus 1. Else I know, since it's not the case, so q dot append probably the left value itself, but this will get reset to 1. And I think so this will be the same case for something like current node dot right. So I will copy this real quick and I'll paste it. So if my current node dot right child exists, then my right value here, instead of left, it will be right value here would be current node dot right. And then if my right value ka data, which is right value dot val, is equivalent to current node dot value, then in that I will append this right node. That's it. And also up here, I think so I need to have something like max length is going to be maximum of my previous max length and whatever my current length is, right? End of the day, I think so I can happily return my max length. Again, this is a weekly premium, so this is the very first problem, week 1, week 2, week 3. I think so that's something which is mentioned here. So let's run this. So it's a wrong answer, right? Let's see. My output is 1, but they expected 3. This should be length, right? length. th. Let's run this. It's a problem again. This is the tree, right, in the example. And I'm getting the output 1. Acha, if value is 0, okay. So it's more like if value is 0, then I won't consider it, right? It's not like the value can be none, but no, that is never going to make sense now. So if current dot left, that kind of means automatically that so if my left value is equivalent to current node value ka +1, right? Okay, my bad. Okay. This should be +1, right? Let's run this again. Yeah, it's running fine. Use example test cases, run the code. This should be a running time complexity of big O of n, where n is the number of nodes. That's it. Okay. Let's close that, and let's use some tags. Let's go for Google. Can solve any, but like let's say Google. We have zigzag conversion. Let's see. I hope so. This is not solved. Yeah, it's not, but yeah, let's see. I think so. Even if the problem is a what do we say? The problem is a premium question. It won't show me right now because I bought it. That's it. And right now it's also showing me the tags. It's good though. Yeah, we have the patch here. Leetcode premium user. Yes, just seen this. Okay, zigzag conversion, right? So I've not submitted this right here. Okay, the string PayPal Leetcode is written in a zigzag pattern on a given number rows like this. On a given number of rows, okay, like this. You may want to display this pattern in a fixed font for better legibility. So pan epsilon YIR. So okay, so it's read this pay, then pal ISHIR ING, right? And then read line by line. Then okay, so this given string PayPal has been written in zigzag pattern of given number. Okay, so this is the pattern they have used to write the number down. So if there was some more thing after G, that would have been coming up here, right? So like right after it would have come right after R. So below G that would come. And then read line by line. So this will be PAHN, APLSIIG, yes, APLSIIG, and then YIR, right? So write the code that will take a string and make this conversion given a number of rows. Okay, so based on the number of rows, that will convert it, right? Okay. This is the function S, and that's the number of rows. I think so. String is number of rows. So let's say this was this, and then the number of rows is 3. So I have to go with this pattern. So why don't I do it for this one, right? So it's PayPal IE. So PAYPAL. PAYPAL. I sharing, right? So I sharing. And let's say if it was 3, then the pattern went like this. It's like 3 number of rows. So that's first row, second row, third row. Characters will come in this way, right? So probably PAYPAL ISHIRING. This was the pattern, right? So in this case, what if the number of rows is 4? So that will be 1, 2, 3, 4. So P A Y P A. I hope so. That's how it would be. Acha, okay. So, okay. So from the topmost thing, it's going. It's a zigzag, right? So it's this. Oh, so if it was 3, then it went like this, and then it went like this. So there's only one thing which comes up, and then this zigzag. Okay, so if it's 4 of these guys, then this, one, this, and then this will come up. Okay. So what if it's 5 of them? Then this will come up, this will come up, this will come up, and then this will come up. So 3 of them will come, right? So it's more like if I have 4 of these, then only 2. So 5 of them, then only 3. Okay. So the number of rows -2, the very first one and second one. So 3 of them comes up, right? Something like that. Okay. So in this case, I think so. Again, this will be PAYPALISHIRING. So if I read it one by one, this will be PINALSIGYAHR and then PI. So PINALSIG YAHRPY. Okay. So can I create a matrix here? I can. So what I will say is matrix will be of length. Also, num rows is only 1000. So that kind of gives away the answer. So let's say, let's say key string is even of length 1000, then what will happen? If we have 1000 rows, then automatically those 1000 characters will be placed here, right? So there's nothing as such that I need to worry about it, right? Because, yes. So what if I create a row of like, let's say 1000 cross 1000? That will make sense because that will cover every single scenario, right? I hope so. Okay, what if the string is of, that will cover everything. So I'll create my matrix of size. Okay, my bad. I'll reload this. Okay, so I'll create a matrix of size 1000 cross 1000. Also in my matrix, I think so this will be a string here. So that kind of gives away the answer. Range, let's say 1001 to be on the safer side. For chain range 1001, makes sense. Now, how do I place these values? It's kind of very naive, right? So num rows I have, so maybe I can use a function called solve to fill up the values. Or do I need to do that even? Let's say my current row is 0, my current column is 0, and I say that, okay, my index is also 0. So while my index is less than the length of s, then I will keep on going, else I won't, right? And then at the end of the day, I will be having my new final string as well. So if my row reaches the number of rows count, then I will reset it back to, then I'll decrement it until it goes to 0. So I can say that, okay, if row is equivalent to the number of rows, also I don't need to take care about the columns, but I think so I need to, because let's say this was my matrix, and let's say I filled up, let's say A here, B here, C here. and let's say my number of rows came up here, it hits here, then I'll decrement by row by 1, so row minus equivalent to 1, but my column will increase by 1, right? So in this case I can say my row minus equivalent to 1, but my column will increase by 1. Makes sense. And this should probably come up at the very end because that's how it will go, right? And let's say if that's not the case, that my row is not hitting the number of rows. Okay, so if row is this, right? So I will do that until while row is greater than equivalent to 0. So I'll do that until my row kind of goes to the very top and I come back here, right? While row is greater than 0, maybe, yes, while row is greater than 0, every time column will increase as well, right? So column plus equivalent to 1. Yeah, that makes sense. And in my matrix at row and that particular column, I will probably fill in the value, which is s of idx. And I'll also say that, okay, row minus equivalent to 1. So while row is greater than 0. So let's say my row hit that point, right? If row is number of this, then I will do this. Column also. So my row hits number of rows minus 1. That's the last cell. So I decrease row, but I increase column and I take the value. Then I decrease row, increase column, take the value until my, let's say, at one time it turns out that, okay, that's 0. So no, I think so it will be greater than 0, right? So let's say at certain time my row becomes 0 and column becomes some value. So it kind of places the value there, but more importantly, when it comes back, it won't go further. So 0 पे stuck होगा, right? 0 पे एकदम रह जाएगा. And then in that column itself, I will continue. What if my row is not equal to the num rows minus 1? Then in that case, I'll say matrix of row column will be assigned s of idx, but like I'll just simply increase the row value. And also by the end of this, I think so in here also I have to put in one condition, while idx is less than the length of s and this, and then also in here I have to increase the idx value, else idx plus equivalent to 1. I think so that's it. So let's look at the row first, then we will look at the other things. So let's say I'm returning some empty string, but I'm printing something, right? So let's look at the matrix for the example, first example. It's getting stuck here, right? Okay, probably because of this, right? So let's say, what if I have this as length of 5 cross 5. List index out of range. Okay, so let's say this is 10 and that's 10 again. And again, that will be only of that, right? So this is going to be of length, let's say 3. Run the code. Yes, so we have this here. Can I visualize this though? No, we don't have the row visualizer, but I hope so. This is what we are looking for. So PAHN, yeah, PAHN is the first line. Then we have APLSIG, APLSIG, and then at the last line we have YIR. So YIR is missing here. Why is that the case? Okay, so let's say it hits num rows, then in that case, maybe I can say that, okay, row minus equivalent to 1. Or let's say row minus equivalent to 2, because simply go the other way around, right? So if I run the code again, yeah, we have YIR included then, but again here that thing is missing out. Okay, where am I going wrong here? So that will be that, yeah. So string index out of range. So this will probably come up here. Let's do that. So PLR, which is again wrong. Yeah. So what's the thought process? So if it's a 3 cross some matrix, so P A Y, my row hits number of rows minus 1, right? Number of rows minus 1, my row hits that value, right? In that case, I say that, okay, row gets here, right? Or I say that, okay, row never gets there. So okay, so let's say my row value was 0. So at 0 P came. Now at 1 A came, at 2 Y came. Now when Y came after that, my row becomes 3, right? My row value becomes 3. In that case, my row is here. I need to get it to this place right here, right? So that would be row minus equivalent to 2. But let's say I don't do that. Instead of that, I simply do this. So row comes back here. Now I'm saying while IDX is less than, then row is greater than 0. In that case, I'm saying row gets decremented by 1. That's the case, but column gets incremented by 1. So I'm here. Now at this place, I place the value matrix of row column. At the row column, and I mean row column, we place the value S of IDX. And then IDX also increases. Now my row decreases by 1. So row comes up here and my column is also here. So at this point, I know that, okay, row is not greater than 0, right? So I get out of this and then I say matrix of row column is S of IDX. So this guy is S of IDX. Now row increases and IDX increases. So this should be good to go, right? Then what is the problem? Num rows. We do have a debugger, right? But I don't know how to use this. Debug, okay. So I becomes 1 and then hmm, watch expressions is also there, right? So let's say I want to watch matrix. I once it becomes 4. Okay, now it's becoming 5. Why is that the case? Why is that the case? Because it should probably stop at that point, right? Step into, and this is step out. Okay, let's say I stop this thing and then click to add breakpoints and all of those things. Let's debug again. Okay, so there is a problem here, I guess. Row is 0, column is 0, IDX is 0. So row plus equivalent to 1, IDX plus equivalent to 1. A better thing, according to me, looks like I can do this instead of that. Let's stop this thing. And instead of this, right? Instead of all of these crap, I can say and then I'll just follow this up with this. So this can follow up here itself. Let's say while IDX is less than length of s and row is less than num rows, correct? In that case, I say matrix of row call would probably be s of IDX, and then I increase IDX, I simply increase row, and yeah, that makes sense. Now when we get out of this, I say row minus equivalent to 1 so that it's normalized, and then I say okay, let's say I'll do that. I think so that should be good to go. So let's try this again. PLR, it's problematic thing again, right? Is it because I have this as length of that 8 or no? No, that's not the problem here. Not able to figure out. Maybe what I can do is can go to this and then try to see how the values are changing. Doing a very silly mistake here. That, and then let's say solution, right? Solution this. So let's get rid of that. So let's say I say print. I've not yet learned how to use the debugger of this, so I'll do that later on. Convert. Let's say my string is this string here. Paste that, visualize execution. So missing 1. Okay, num rows is missing, so I'll put in 3. Close. Last we see this, but why is that the case? Like, oh, so PLR is fine, right? Or no? PLR, no, it's not. No, it's not at all. No, not at all. So all of that things going to happen, and then I'll get to a point. Yeah, so initially my row and column is 0, right? Okay, this is what my matrix looks like. So I'll put P there, and then A will come bottom, then Y will come, then P will come at 1 comma 1, right? Yeah, p comes there, and then a will come at 0 comma 2. Yeah. Okay. Oh, okay. What was that? So a came there, right? When did a came? A came right here, and then I increase the index. So index increases by 1, 5. So index is at 5, right? So L pair. Okay. Now row is greater than 0. So maybe just a very small thing here. I'll just say that's it. PAHN, everything looks good. So end of the day, I just simply need to loop into this. And let's say my answer string is empty. So for I in range, um, let's say this was num rows, and let's say this was 1000, it does not matter. And in this case, I can simply say, what can I say? We'll have 1000 of these rows. And then for j in range, num rows. Okay, it should be num rows, my bad. And this should be 1000. Yes. So answer plus equivalent to what do we say? Matrix of I and j, and then I'll return answer. I think so. That should be it. Let's see. Run code. Yeah, that's it. Use example test cases, run code. Accepted. Let's submit this. If there's a runtime, I mean time limit exceeded, then I know where to look into, because time limit exceeded for something like an AB. Okay. AB and then it's 1, right? That means what if I provide? So let's say I provide 1 here, and then let's say this is AB. So am I stuck on a for loop or something, or? So in here, this is how it gets initialized. Makes sense. And then I'm saying key. So row is 0 and column is 0. Yes. While IDX is less than length of S and row is less than num rows. So I go in this, and okay, I have not yet increased IDX there as well. No, I have, right? I have increased. Okay. At any point, if I see, I'm going to say break. So right now, A, B, and 1 will, sorry, be fine, right? So test cases. Okay, let's execute this once again. That runs fine. So let's do that. Let's run the code. Should be fine. Please, should be fine. Okay, come on. So if I introduce something like if I execute of S, I'm saying break, right? So what's the problem now? Okay. So in here I see, why is it not breaking out of this? I mean, it encountered, right? If IDX is length of S. So I think so IDX is never getting increased by from 1. Oh, I see. So, okay, so let's say this got created, and in here I know that so row and column are 0. If no, that's not the case. So while IDX is less than length of S and row is less than num rows, right? So num rows is 1 in here, right? That kind of gives away the answer that A will come up first. Or I can even say something like this is again an edge case I see. If num rows is equivalent to 1, then in that case I return S, because that will be as it is, right? Because but 2 ke liye bhi it could be an edge case. Let's see, we never know. Okay, it's running fine, but it took me a lot of time. This was an edge case, so I'll write it down here. That's it. This is also not required at all, and I'll resubmit this, just to make sure that everything is inbound. Okay, let's close this and that. Let's do one more and then we'll head back to our base. Zigzag conversion, that's done. Swap nodes in pairs. What is this? I don't know. Okay, let's see this later on. Remove element. This is binary search, I remember. So never makes sense to go for it at the first place. This is recursion. Something which I don't know. Validate, kind of, I know. This looks interesting. Decode ways. Have I done this though? I haven't, right? Submit. Okay. A message containing letters from A to Z can be encoded into numbers using the following mapping. So A is for 1, B is for 2, and till 26. To decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. There are maybe multiple ways. For example, 11106 can be mapped into AAJF with the grouping 11106. Okay. KJF with the grouping 11, 10, and 6. Okay. So it depends on how I see this 11, 10, and then 6, and then so on, right? So note that the grouping 11106 is invalid because definitely 0 is not something which we can do. 06 is something we are not interested in. Given a string S containing only digits, return the number of ways to decode it, right? So I have to find out, like in this case, this was first way, second way, and it could be multiple ways. So I have to find out the number of ways, right? And let's say S is 12, and then I'm saying output is 2. So because of what I mean, 12 can be thought of as L, or it could be AB. 226 can be 2, 2 and 6, or it could be 22 and 6, or it could be 2 and 26. So that makes sense. And this is of length 100. Okay. This should be having a tag of Amazon, Cisco, TikTok, Facebook, Google, Microsoft, Lyft, Commvault, Goldman Sachs, and Duolingo. Okay. Did I pronounce the name correctly? Duolingo. Don't know. Okay. This is 100, so I can go for a n square or n cube as well. That makes sense. Not n to the power 4. So n cube log n is also fine. But let's see. So what I'm thinking of is 226, right? So I'm thinking of 226 as follows. So let's say 226, my index is here. So maybe I will say that, okay, in my first segment, let's consider 2. Let's consider 2 as part of our current segment. So my current segment is empty. So I'll say that, okay, let's consider 2 here. Done. Now 2 has been considered in the current segment. When I go to the next one, I have the option to consider this as the separate segment, or I'll add it with 2. So here I have the option to have 2, but here I have the option to have 2, 2 or 22 as in whole. Here at 6, we have the option to have 2 to 6, but should I even go for this? No, because that will never make sense to even go apart from 2 digits, right? So on that note, I can say that, okay, 6 can be taken alone, right? So that's how many ways. That's picking 2, then this separate 2, then 6. So that's one way. Picking 2, 2, and then 6, that's one more way. And one more would be that, let's say I picked this 2, and this separately I'm picking. But this 6, let's say instead of picking it separately, I'm saying that, okay, let's combine it with the previous value. That would be 2, 6. So that's 3 ways. But how do I do that though? So let's say I can say I have to keep track of previous and current segment. So let's say my previous segment had 2. And I'm at this 2. So my new call can be simply previous segment will be as it is and my current will be 2, or my new call would be my previous segment as nothing, right? So I don't need to have anything. So let's say -1, and then this could be, so okay, so let's say 2, 2, 6. So I'm keeping track of previous and what's my current. That's it, previous and current. So let's say when I start, my previous will be -1 and my current will be empty. So when I start, I know it's -1, so I can take this 2. When I take this 2, I call a function. So my previous will be 2 and my current will be empty. So here I think so I have 2 options. Current is there. So I have 2 options that I can go with previous 2, 2 and my current will be empty. Or I have the option to go with previous as 2 and my current as this, right? Current as empty. Yeah, I think so. This kind of summarizes the answer, because I can have something like 22 and 6, 2, 2 and 6, and 2 and 26. How did I achieve this? That's something I have to figure out. This is like a recursive tree diagram, right? So from 2 to 6, I take 2. And then from 2, I have the option to take this 2 as a whole or split it, right? And then this 22 could be paired up with 6 in this way itself. And I cannot have something like 226, so that's neglected. I return back a -1. So wherever I find out that the number of characters included right now, the number of characters included in my current string is more than 2, I will say that okay, that's not something which is valid. And also whatever the string representation of current is, I'll take an int of that and I'll say that okay, if that's less than what do we say? Okay, I'll say that okay, whatever the string representation is, it should be less than a string representation of 26, less than equal to that. And also 0 should not be at the very beginning because that's never a number in, so it's from 1 2 3 till 26, right? So at 2 I start with 2. At this 2 I have the option to take 2 or I have the option to go with separate 2. But this 2 which I'm taking in, or the current string which I'm forming, should be valid, right? Next step from here, if I form 2 to 6, this is not valid, I can't go further. Or I can form 6, I can form with 6, and when I know that index reaches the very last, I'll return 1 because it's a valid thing. Yes. At this 2, at this 2, I have the option to take in 26 or simply 6. Then I move forward with index. Okay, so this will look very simple. In a simple way, this would look something like this. Result would be solve. Index I'll pass 0. I'll pass in s, and I'll return the result. So let's say define solve. My index is there, s is there. So, or let's say my current string will be also there, which is currently empty. So I can say that okay, if what's the base case here? Base case is nothing but that okay, if my index reaches the very end, then I'll return 1. Else I have to find the faulty cases wherein like the current string which I'm forming, that should not be something I'm interested in, right? So also this s can start with zeros, right? So let's say since this is the very first time, I can have -1. Current, right? So if current is equivalent to -1, so I know this is the very first time. Also I'll have something like this, that okay, if s of 0 is equivalent to, let's say 0, in that case I'll simply return 0. That's again an edge case, because I can't do anything with that. If current is -1, then I know my current will be by force, that would become s of idx, and then I'll call a function here. So number of ways I can say that take s, and then let's say I will not take s. So if I take the current, then I think so in that case or let's have it as empty now. Let's not do that, and let's simply say current plus equivalent to, okay, so let's say new is equivalent to current plus s of idx. Now I'll simply check that okay, if my new is fine, then I'll take it, else I won't. So I'll say that okay, let's check validity. So if new of 0 is not equivalent to 0, and probably length of new is less than equivalent to 2, and new is less than equivalent to the character representation 26, then in that case I have the option to take it. So that would be take. If I take it, then I'll call a function at solve idx plus 1, s will be as it is and current will become new. Else I have the option to not take it, and that would look like this. So solve of solve of the current character, right? That's it. So idx plus 1 s, and whatever my current character is, that's s of idx, and then I will return total number of ways would be what if I take it and what if I not take it, right? And then I'll return the number of ways here. I think so I'm doing a lot of work here, but let's see. For 12, the answer I'm getting is 4, but expected is 2. I know why that is. So I will say that if new is equivalent to s of idx, sorry, if new is not equivalent to s of idx, then not take will come into the photo, because I don't want to do the operations over and over again. That is fine. Use example test cases, run code. That's fine. Let's submit this. Why does it look like a dynamic programming problem to me? Let's see, who knows? Okay, it's giving me a wrong answer. So for 9, I'm getting an output as 0, but the expected is 1, definitely. So what's the least I can do here? So new becomes current plus s of idx, which is 9. And I'm saying new of 0 is not equal to 0, and length of new is less than equal to, and new is this, right? Take would be solve of idx plus 1, s of new. So idx reaches end and it returns 1. So take is 1. And then I'm saying new is not equal to s of idx. Yes, that's the case. Okay, so 9 is not equal to s of idx. No, that's not the case. So 1 plus 1, it should return 1, right? At least it should return 1. Why is that the case? So new is 9, right? New is in quotations 9. And I'm saying 9 is not equal to 9, then not take aayega hi nahi. Okay, so let's copy this thing now. See once again where we are going wrong. So print solution dot num decodings, and then we have a simple 9 here. What's happening here though? Let's see. Last we are getting 0. Why is it? So take will, okay, new is what, 9, right? Okay, so int representation I need, right? So I can say int of new is less than equivalent to 26. That's it. इतना सा मैं क्या अभी चेक करेंगे जाके. वन जीरो राइट, तो ये 1 बन गया, and this is kind of fine. Now take goes like this. So if I take it, I go to 0. Now at 0, I know that 10 is one possibility. So it again goes in here and goes at the end. So it returns 1. So take abhi 1 ho gaya, right? Now I'm saying at that point 10 is not equal to 0, right? Again I'm calling this. Okay. So will I call it with this? No. If and this will be simply s of idx. I mean replace with s of idx. Then I will try to call this for 10. Let's see what the output is. So let's use the example test cases first. That's fine. Let's code for 10. This is also fine. Let's submit this. I think so. There is a application of dynamic programming here. I feel like I have a strong feeling. Hash map. I'll just quickly do that. If it's not the case, yeah, time limit exceeded as expected. Hash map, and then I'll say, let's say hash map up. What's my state? So my state will be memoized with ways. Now what's my state here? State would be nothing but index and my current. That's it. Index and current. And then I'll say, okay, if my state in hash map, then return hash map of state. Else do that. So let's run the code and let's use it for example test cases as well. Run code. And that is fine. What I'll do is, as a part of next step, I'll copy that and paste that here. That will make a lot of sense. Let's run this. Should probably run fast. Submit this. So basically, yeah, it runs good. It's a good problem. It's a medium one, right? Yeah. So basically, like I'm memoizing the current index and whatever my current character was. That's it. And this will be of length, indexes of length 100, right? So the extra space complexity would be probably this. The extra space complexity would be whatever the length of that is multiplied by this current is never going to be of length greater than 2 because I'm checking this condition here. Hence that will be 2. So n cross 2 is the space and the time complexity is n cross 2 as well. Both of them for this code. Okay, I'll close this and I'll